make you aware, this is an Oracle server here. This is the client I'm going to be attacking from. This is running on XP. It could be Linux, it could be Windows 2000, it could be any system. The attacks are still the same. Obviously, in terms of exploitation, there's slight variations, especially when it comes down to, well, more than slight variations, especially when it comes down to exploit code for buffer overflows, etc. Okay, so before we can successfully attack an Oracle system, we need to gather some information. For example, what version is it running? You'll find that in the authentication procedure, by supplying an overly long username, you could overflow the RDBMS itself and gain different dependent upon the version. For example, 8.1.6 would be completely different for 8.1.7 and so on, all the way through to 9.2. So you have to know exactly what version you're dealing with. Platform is especially important. If we're dealing with a Linux box, then our approaches are going to be completely different for that of a Windows system. SIDs, these are the service IDs. The service IDs, Oracle instances are given service IDs. Pretty much gather that by examining all of this information through the listener. So what is the Oracle listener? The Oracle listener can best be described as the hub of Oracle communications. When clients wish to use RDBMS-based services, they go through the listener. They connect to port 1521, say to the listener, I'm interested in connecting to this SID. The listener will then tell the client, connect to port, some random port, 1489, whatever, and the RDBMS will be listening on there. When the actual database server itself starts up, an instance starts up, it registers with the listener and deregisters with the listener. When you call external procedures from PLSQL packages and procedures, that goes through the listener. The listener then launches xproc, and xproc is responsible for executing the external procedure. We'll be discussing this later on in further depth. But as you can see, the listener is key to the success of Oracle communications, everything moving around successfully. If the listener is killed in any form or fashion, then communication breaks down, nothing works. We will use the listener control utility to examine the listener. So we're doing our information gathering here at the moment. So if we come through, can everyone see? Let me move that along. Okay, this is the listener control utility. We need to set the current listener to this box here. Let's put its IP address in, and then do a status. Okay, from the top here, the alias of the listener is listener. That's the standard default. From here, we can see the version is 32-bit Windows. It doesn't tell us exactly what operating system it is. It could be XP, it could be Windows 2000, it could be Windows NT4 even. So we know it's 32-bit Windows at a minimum. What's important here as well is we can look at this and see that security is off. What that means is there's no password being assigned to the listener. That's a bad thing. That's the default setting, by the way. Uptime has been up for an hour. These are the services that are running. PLSproc, that's important because we'll be using that to gain control of the RDBMS without user ID and password later on. The service, one of the SIDs, one of the Oracle instances is XPNGSS, and we have the XDB equivalent as well. XDB is for like XML database. Another interesting point to note is there is a service listening on port 8080 and 2100. Now these are all to do with XDB. I found a buffer overflow in there last night. Now that is truly 0 day, but I'm not going to speak about it because there's no patch just about to be a release for that. The zero day I'm going to be speaking about today, there is a patch available just shortly, so I'm not going to speak about the one I found last night, but I mean, this XDB stuff looks like it's got a lot of problems with it, and so if you're interested in researching Oracle, I'd say look in that area. The port 2100 is an FTP service. Port 8080 is a web service. Both require authentication, however. So using the status command, we've gathered useful bits of information. We've got the platform. We also have the version information here. Another interesting point, actually, is if you've got an IDS system set up to look for things like status commands or service commands, whatever, we can actually, I've got a wee program called TNS that basically uses, how to say, I didn't reverse engineer the TNS library. I looked at what packets were going across and basically you're replaying those packets. Now if we send if we send anything, it could be gobbledygook, we should get an error message back. Now here we have vs_num and then a number, which doesn't look like much, but when you convert that number into hex, we can see it's 9200100. So they've got some strange thing going on. The point of bringing this up is we can still get the version information without actually making any valid TNS call. TNS, by the way, I think stands for Transport Network Substrate or something like that. It's Oracle's protocol basically for communication between clients and servers and so on. Transparent network substrate, that's what it is. So we can get useful information using the listener control utility. All the information we're pretty much going to need to actually make a successful exploitation of the system. And I just thought it was, interesting that the VSN num in decimal, when you convert it to hex, gives you the version number out. Something to bear in mind. We can enumerate users by, if you're trying to crack user accounts, you have to have a valid user ID and you also have to have a valid password. Without a valid user ID though, you could be smacking away at an account which doesn't exist. So if you want to verify whether an account exists or not, SQL plus W. Okay, system, the account exists. Put in an invalid password, XPGSS. Now you need to sniff it. Okay, we get an invalid username/password logon denied. But if we look at the packet capture, here we're connecting to the listener on port, it then tells us to connect to port 36. And we, go through the three-way handshake, TCP handshake, and then connect. We then, here's our first authentication packet. You can see here, maybe those at the back can't, but here is our username, system. That's who we're attempting to authenticate. We will be issued an auth sesh key. This basically is used to encrypt the password going across the wire. If we use an account that doesn't exist, password XPNGSS. Again, we connect to the listener tells us to connect to another port. So here is our invalid user, DFJ, FHJ, whatever it is. You can see there's no session key. We basically get a wee packet sent back to us. I don't know if you can see in the bottom hand corner. Let me lift up my laptop, see if you can. Okay, it's the packet is basically 00, 0B, 00, 00, 0C, 04, 00, 00, 01, 0001. That basically tells us that that user account doesn't exist because it didn't offer us an auth session key, basically. So we can immediately determine whether a given account exists or not. Now, if Oracle auditing of create session has been enabled, even if you terminate, tear down the TCP session at this point, because we only need this packet to determine whether the account exists or not, even if you tear the TCP session down, before you get this invalid username password thing, the attempt is still logged. The create session attempt is still logged. So you will not bypass auditing using this, even if you do tear down the session fully completed. But it's still an interesting thing to know that enumerate users this way. Okay, next. So recapping SMTP, it's guesswork. You have to say, does user David exist? Does user Bob exist? And so on. And if so, we should or not. And again, if create session is enabled, these attempts will still be logged. So if you're an Oracle DBA, doing some AUD $ where ID equals, I think it's 1718, that's the thing you're looking for. That's a failed authentication attempt. You'll be able to see if there's a lot of this going on. Okay, command insertion. Using the listener control, we can basically, if security has not been set, and indeed it hasn't, what we can do is actually, we can set the log file such that we overwrite, say, the autoexec.bat. Alternatively, we could create a batch file and put it in the administrator's startup folder. Various different things we could do, and put a bunch of commands in there. So if we use the listener control, set current listener. Okay, set log status on. Okay, we now need to set check out current patch from there, set log file. Just for example, ccon /autoexec dot bat. Autoexec dot bat. We then insert a command using the ampersand, because when a batch file runs, I'll just show you TNS 10.1.33 ampersand dir. Okay, that should have now been logged to the log file, and if we then set the log file back to what it was, I just set it to something foo.txt for the time being. Okay, so in our autoexec.bat, how am I going to do this? Okay, use now don't write down my password. I'll just do it the other way around. Make a copy. there's the autoexec.bat. Okay, I've actually screwed this up. I mean, my command will be in there, but the logging is set to like extremely high, so everything is going on. So anyway, if we were to run autoexec.bat now, we'll get a lot of could not run XYZ command, blah blah blah. But the command we actually put in there will actually run, or should do, once we go through all these.
I think you missed that. You misspelled it. You actually put an accent service.
Did I not? Oh, I did. Thanks. Okay. Right. Okay. Sorry about this. Do it one last time. Like set log file.
Still have an accent.
That one. Autoexec.bat, yeah. Right. Access is denied. Great. Yeah. I just didn't copy across. That's the only problem. Right. Paste. Let's see. CD. Count. I mean, this really isn't that exciting. I don't know why I'm actually spending that much time on it. Nearly there anyway. Okay, finally. So, the autoexec.bat, if I has a couple of entries. The 15th of May, log file, TNS 01153, failed to process string ampersand dir. So if that was to run, autoexec.bat, you know, because of the insertion of the ampersand beforehand, the command runs. As I said, we typically put this in the, you know, the administrator start folder, so when they log on to the system, bang, it goes. So moving on. Okay. About a year ago, there was a problem in Oracle whereby we could pretend to be the Oracle process and force the listener to launch extraproc for us, load a library, and execute a function and pass it any parameters we want. The whole reason behind this kind of functionality is to enable external procedure calls from PLSQL. So what actually happens is the Oracle database connects to the listener and says, please do this for me. The listener launches xproc. The listener then tells Oracle, connect to xproc, and Oracle tells xproc to load the library. They fixed this in 9.2. So let's look at how they fixed it. You must be local, and the library must be in the Oracle home directory. Now, I'm going to show dir. Okay, if we were to try and do a valid thing from, again, this particular one requires a user ID and password. You know, I'm just showing you the functionality that's being abused. Okay, we run this. Basically what we're doing here is creating a library called exec shell and telling it to use msbcrt.dll in the Windows directory. We then create a package around that called exec and call the c.dll. If we then try and exec that with the fixed version, we should get invalid DLL path. Yeah, so here we have to fix that, to ensure that you're in the Oracle home directory. Unfortunately, it's vulnerable to a double dot attack. So here as /oracle /aura92 /bin Windows system 32 msbcrt.dll. So hit enter, and no invalid path this time, and it's a pity we don't have two screens actually. The NGS software user has now been created because Oracle is running the system. So the other thing is if we're local to the Oracle box, we can still, without a user ID and password, launch xproc and execute commands via msbcrt.dll in the same fashion. But that's only if we're local. So that's typically going to affect more Linux boxes kind of, or Solaris, where you've got multi-user systems and people telnetting and so on. The other problems with the fix are, there's a directory traversal we've discussed, and these days if you attempt to launch xproc remotely without user ID and password, the attempts are logged. However, in doing that, an overflow occurs. So we can still gain control without a user ID and password. Showing that. Right. Actually, I should have pre-made command. Right, I'm going to set netcat listen on here. Tools, access, NCE, P53. Okay, so we've got netcat listening on port 53 on box here. And we'll sniff this session just to show it in action. Okay. 9.2.0.1 blah blah blah. As I said, depending upon the version of Oracle you're dealing with, it's highly specific. Things change completely. 3 is the box. PLSproc is the SID for xproc. Sometimes it's xproc. It can be a number of different things. So you have to put whatever it is. This is the IP address of this box. That's where the shell's listening. If I wanted to spawn a shell to a different box, you could put that in. And we with user-supplied input. So what we need to do is overwrite the save return address on the stack with an address, a jump ESP instruction, and through various other methods you can work out this is actually running XP, and you should know, opcodes in. Now, the code behind this, this is the only thing we actually need to hard code in, pretty much. The rest of the code it basically passes the P header, looks for looks for the addresses of load library and get proc address, and from there the rest. So there's nothing hard coded in this. I don't know whether I'm going to publish this code after what happened with Slammer. Someone used that as a template for the Slammer bug, but that's something we'll discuss later on. So anyway, firing this off. So we've connected to the listener. The listener's told us to connect to 3841. And there's our shell here. As you can see, we're in Oracle Aura 92 RDBMS trace HS core 02936. This actual end part of the directory is built dynamically as and when a library is created. So even though we can't load a library and execute a function, in the process of it being logged, we can still gain control by exploiting the buffer overrun here. So if as we're in the system, we should be able to add listener password and then /add. So we've now managed to successfully create a user account called listener and so on. So the patch for this is just about to be released. Actually, we're just about to talk about defenses anyway. Okay. First off, set a listen password. That will prevent attacks such as using the log file to insert commands into script files and so on. By setting a password on the listener, most of the dangerous administrative functions you have to supply the password for. We can still, of course, do things like status and services, so we can still gather information. Set admin restrictions to on. Admin the modification of things like log files, trace files, and so on. The more dangerous functions available through the listener are disabled. Entries in the listener.aura and tnsnames.aura for anything to do with xproc, that will prevent the attacks based upon xproc, whether you're running 9.2 or earlier versions. If you're running versions of Oracle, then we can just connect to xproc library to execute a function with 9.2 and onwards kind of thing. We can still gain control through that buffer overflow. Use TCP valid node checking. Essentially with Oracle, you can say allow these hosts to connect, but disallow these hosts. Now, and an exclusion node list. The invited nodes take precedence over the excluded nodes. So, for example, if the administrator had made a mistake in www.hacksaw.com and by accident put that into the invited nodes, the invited would win, and so you would still get access. So it's best probably just to plump for, invite everyone you want to invite, but disallow everything else. Don't even bother with excluded nodes. Ensure file permissions are strong. The listener password is stored in the listener.aura, so obviously if we can somehow get access to the contents of the listener.aura, then setting a password is pretty much a moot point. So ensure that only the Oracle user can access those files. Enable auditing of create session. That will capture attempts to enumerate users, attempts to brute force user accounts, known user accounts, and so on. Obviously, if someone manages to succeed, then you need to start auditing other things. But at a basic level, at a minimum, you should be auditing a create session. run the Oracle services, such as the listener, the RDBMS itself, and everything else, as a low-privileged user. That way, if someone does find a new buffer overflow or whatever, they're not going to be able to control over the operating system as well as the database server. At the end of the day, though, when you think about it, a professional hacker is not going to be interested in gaining control of the host. It's going to be the data thereafter. Even if it's running as a low-privileged user, your data could still be compromised, and that's probably the greatest risk of all. And of course, finally, patch. There's obviously a need to test patch, to define a policy or procedures at least for when a patch is announced by Oracle to test that patch in a development environment that mirrors your production, and as soon as you're ready, get your production systems patched, because the longer they're unpatched, the more likely they are to be compromised. Yes. All systems, Solaris, Linux. Oracle developed Oracle, the RDBMS for about 60 odd different operating systems. The way in which you gain control is going to be completely different, Any other questions? It's, you don't know whether you've done well and I've explained everything perfectly, so there's no need for questions, or whether I've just bored the tits off everybody and it's like, Sorry, go ahead.
Could you really want to release this exploit code because of the problems that happened with Slammer? Could you expand upon that?
Yeah, back in July of last year at the Vegas Black Hat, I talked about the hole that Slammer exploited 6 months later. And within that talk I presented some exploit code. Now, they took the way in which I gained control of the SQL server by using, imports within qrsort.dll for the import address entries for get proc address and load library and so on. They took exactly that information verbatim and pasted it into their code. The engine created a reverse shell. There's obviously, went around compromising as many systems as possible kind of thing. But they used my code as a template. Now, there were a number of me, if I hadn't have released my code, Slammer wouldn't have existed, and well, I don't think so. I just think I'd probably saved them 10 minutes time in a debugger at the end of the day. What I'm wary of these days is by releasing code like that, whether the same thing will happen again. I mean, especially as this does. It's an unauthenticated system compromise essentially. So if we had to, at least have a valid user ID and password first, then that would halt the progress of a worm. Of course, they could go for the defaults like DB and SMP with the password of DB and SMP and so on, and put that in the worm as well. But it's definitely much more dangerous releasing exploit code for a problem that requires no user ID and password, because therefore it's much more easier to automate and so on. Sure.
There's a trend currently using the Java code procedure within project, from which it's also possible to execute shell commands.
That's correct.
And more easily without more restricted loading. Have you been working already on this?
Yeah. Have you seen Eric Buckholtz's book, Special Ops? I wrote the chapter on Oracle in there, and I spoke about this using Java to execute commands and stuff like that in that chapter. Being honest, there's when you get gut feelings for there being a problem in a certain place, and I've got loads of those gut feelings. Now, Java is one of those where I've delved into it to a certain level and need to do the rest, and there certainly looks like there's going to be a lot more problems there. Another one is, and again I haven't researched this, it's just one of those feelings where it's like, well I'll explain anyway. Back early on when I was speaking about the listener, when the RDBMS registers an instance with the listener, it says, when someone calls me, launch this program. So, hey, we could just pretend to be an Oracle instance and, say, launch this program when, connect to the listener and pretend to register as an Oracle instance kind of thing and say, when someone calls me, launch this program kind of thing. So there's a potential there. I haven't verified it though, and I could be wrong, so I'm quite happy to speak about that. There's no proven vulnerability there. Selling the XDB stuff, there's a number of problems there as well. So if you're interested in researching Oracle, look in that area. Sure.
On your defense board, you talked about,
Yep.
you said PPP. I'm not really right here, but I want to just clarify what those are being done. Can you just clarify the movements on where those second are?
Yeah. Okay. TCP valid node checking, I think, is done in the SQLnet.aura. File permissions, obviously, that's just the file permissions. The listener password is set in the listener.aura. Admin restrictions is the listener.aura. And removing entries for xproc and so on is in the listener.aura and tnsnames.aura and so on. And enabling of auditing can either be done directly editing the init.sid.aura file or the SP file, depending upon the version, or you can do it through SQL plus, auto system and so on. Any other questions? Sure. Yes, I'll need to give it to Jeff, and it will be posted on the Black Hat site. As I said, I'm not sure about the code yet, but Jeff and I will probably have a discussion about that. I might cripple it in some way, so it can't be cut and pasted. No other questions? Sure.
Just to expand on what you were saying earlier on, I will actually personally enable you for this work, not keep the relatively system being connected to the internet and unpacked. Would you not feel by saying, well, actually, I'm not going to do this again to make your bound their pressure?
Yes, in a way, but I feel somewhat responsible. I know I didn't write the run. I know people should have patched, but then I still had a wee role to play. So I'm not necessarily bound to their pressure. I'm bound to my own shit. This isn't a game. This can have an impact upon people, a real impact, and so on. So it's made me tread more gingerly, put it that way. Talking about people not patching, I think the problem with Slammer was everyone patched their SQL servers, but everyone forgot about their MSD install. I mean, when you install things like, Office Developer Edition, you get MSD, and if you think about the number of installs of things like that occurred between July and when Slammer actually hit, there must have been millions of instances of new MSD installs coming up, and people just not knowing it was there, so I think that really was lend itself to the success of Slammer at the end of the day.
Yeah, it's still going on.
Yeah.
17,000 was obviously Slammer too.
Cool. Well, not cool, but Any other? No? Cool, well, thank you very much for coming and enjoy the rest of the show. Let's move it up a little bit. Actually, I'm waiting for a water refill. Wasn't planning for that one, but I'm not sure about.
Let's go. 42 minutes.
Okay, well, start anyway. First of all, welcome. My name is Hilton Haas. I end devices and digging into the more closed systems, with a lot of open source stuff. As part of that activity, we did look at a system or a thingy called the XDA, which is a typical pocket PC device sold here. So the XDA is sold all over the place, here at home under the name of XDA by O2. So, and what we had was a group of people interested in what this device is. Not from a security point of view, but just from what can you do with such a device, how does it work. I was part of that effort and still am, we are still looking at it. But because of my security angle and my experience, it's always interesting to look at it a little bit more from a security perspective and see what it means, the things that we can run into when we look at such a device, what that might mean security-wise. So basically the presentation is quite simple. First of all, I want to just dig in, show you what a Pocket PC is and what a Pocket PC phone edition is. So what's specific about it. Then go a little bit into, okay, horror scenarios, what security-wise is scary about such a thing. Show you a little bit of features that they build in, balls that they also build in. Last part is tools of the trade. What kind of tools can you use to look at such a device? See what it does. First of all, if you have a question anywhere during the talk, don't wait to the end, just ask a question. Best to take it on when it's fresh. What is a Pocket PC phone edition? First of all, maybe a little bit broader, what is a Pocket PC? What is a PDA? And not so much, okay, what is all the features that it has, but what is the functionality and what are the requirements that make these software side of the devices. First, best known is PAL, although already it's a little bit sinking to the background in the sense of if you're looking at phones and if they integrate phones, I guess also maybe the US versus Europe thing that is not so strong here anymore, I think. Then you have, they have Palm OS, their own OS that they wrote themselves. As far as I know, there's no real phone type available. They do have something that you can integrate with some carriers and expensive and stuff like that, but they don't have a real phone type. Then there's Symbian. Symbian is an organization, so it's not a company, well, maybe it's also a company itself. It's mainly founded by an alliance. And it's based on Epoch. Epoch was the OS that ran on silent devices. And especially Nokia and Ericsson are pulling this development. So they created Symbian OS, made a lot of specs, opened it up for development, and put it in the newest phones. So if you get new Nokia phones or new Ericsson phones, then often they contain some version of Symbian, and also Symbian development tools that go with it. Finally, Microsoft also went in some move towards supporting, first of all, PDAs, but later on also phones. Their version of OS is called Windows CE. It's an embedded version of Windows. It's kind of a weird thing to go into a little bit later, but that's their main OS. In the marketing things, it's called Pocket PC. In the development department, it's called Windows CE. Okay. Windows CE, you have to imagine the difficulty that these people have is they want to embed their software in a small device. Only what's small, and when do you measure it? If you look at the development,
How many CPU cycles, how much RAM or ROM is in the device and how fast it goes, you can clearly see that they didn't envision such growth in power in such devices. So they used to think much smaller than they actually now